So we're ready to begin our next big unit. We've had a unit on inorganic chemistry, then we focused on organic chemistry, and now we're going to take the information that we've learned along the way and we're going to apply it to biochemistry. So you're going to be introduced to the topics of biochemistry here in this little unit and actually focus on our first type of biochemical compound called carbohydrates. All right, so what is biochemistry? Biochemistry is the study of the chemicals that make up our body. So whether it's a plant or an animal or us ourselves, these are those chemicals that are in there. Now, a lot of the organic molecules and those functional groups that we learned about in our organic unit are going to be applied to this world of biochemistry. So, like I said, these compounds are organic. We're going to focus on three main topics. It is a vast world out there, and there's ones that we're going to leave out. But we're going to focus on carbohydrates first. We're going to then go into fats and oils, and then we're going to finish our discussion with the unit on proteins. So let's start with carbohydrates. I want to introduce to you this concept of what a carbohydrate is. The things that fit underneath that category of carbohydrates are your sugars, so you're familiar with a sugar. The term saccharide is a fancy way of talking about sugars. The term starch and the term cellulose, all of these things fit under the umbrella of a carbohydrate. So if we look at that word, carbohydrate, and break down what the word means, we see two words in there. We see carbo, and if we stuck an N on there, that would be carbon, okay? And we see the word hydrate. And somebody said, man, I'm dehydrated. I need to get hydrated. What do you think about? You think about typically the term water, okay? So we see the word carbon in there, and we see the word in there of hydrate. Carbon hydrate. So that word hydrate, when we think about that word, we're thinking about water, and I don't think that's going to pop up there. Yes, it does. The addition of water is the word hydration. So when we start putting water in, we are hydrating. So if we look at the formula for our carbohydrates, they generally break down to carbon and water, but they're multiples of this. So it might be C6H12O6. It might be C5, that's not a C, I don't know why I wrote 5 twice, C5H10O5. Notice that that is a multiple of some variety of this grouping, one carbon and one water repeated. Now, we're going to look at the structure very closely as we proceed on, but that is the breakdown of the word carbohydrate. Well, it's not wanting to advance, so let's see if I can make it advance that way. There we go. So, the word monosaccharide, we see that prefix mono in there. When you hear the word saccharide, you want to think carbohydrate always. So a saccharide is a carbohydrate. It has the carbon, it has the water, and it has multiple units of that. So saccharide is just referring to carbohydrates, and then we have the term mono associated with it there. So we know that mono means one, and this is the simplest sugar. So sometimes we call them simple sugars. One sugar unit in a monosaccharide. When you see the names of these guys, we'll see the the suffix OSE. So when you run across a monosaccharide, they very often will have that word OSE associated with it. So there are some sugars that you'd probably be familiar with. We're going to look at glucose and we're going to look at fructose kind of closely at first, okay? So here are the two molecules, glucose and fructose. Glucose has got a 6-carbon ring, so we remember there's a carbon here, a carbon here. The carbons are not being shown, okay? There's a carbon at each one of those points. We see the carbon right there, okay? And it has 6 carbons. And it has, so let's count them, all right? 1, 2, 3, 4, 5, 6 carbons, C6. It has, let's count the hydrogens. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it has, counting the oxygens, oopsie, I don't want to go that way. Counting the oxygens, it's got 1, 2, 3, 4, 5, 6. All right, so that is the formula for glucose. Now I'm going to erase all of that just so that it's not cluttering up my screen quite so much, and then we'll move on to what the fructose looks like. The fructose has a 5-carbon ring, all right? So there's a carbon 1, 2, 3, 4. I mean, sorry, a 6 is not, it's not a 5-carbon ring, it's a 5-atom ring because the oxygen is the 5th one in that ring, okay? So I have 4 there, I have another carbon here, 5, and I have another carbon here. So again, I have 6 carbons. And if you stop the video and count the hydrogens and oxygens, which I suggest you do, you will end up with C6H12O6. So we have 2 molecules that have the exact same molecular formula, C6H12O6, but they have a different 3-dimensional structure, have a different connectivity of these things. So these are isomers of each other. That's a term that we learned when we were talking about organic chemistry. Okay, so like I said, both of them have that formula, but they have a different arrangement. Now we're going to practice building glucose and fructose later, and so we can see what it looks like in the 3-dimensional world, because this isn't a great depiction of it. This makes it look like these rings are nice and flat, 6-sided ring and a nice flat 5-sided ring, and it's not. There's got a lot of twists and turns to it that we'll look at later. Okay, so that right there is the end of our just introduction to what biochemistry is and the beginning of our discussion of monosaccharides. We're going to look at monosaccharides, then we'll move to disaccharides, then polysaccharides, meaning many. So that will be our world of that. We're going to start building with our molecules in class, and we're going to link them together to make the disaccharides and the polysaccharides.